So for this lesson, we are going to be leaning quite a bit on Desmos because we are going to be solving nonlinear systems of equations. So we're going to start out with equations of a line and a quadratic. So you can solve these graphically or algebraically. We're actually going to start out with those algebraic methods just to get them out of the way. So then we can jump into using Desmos with the more complicated equations. So on example 1 here, we are given two equations, and one of them is quadratic, and we know that because it has that exponent of 2. So it is solved for x, and so for this one, I'm actually going to use substitution. So I am going to substitute in that 2y squared plus 3y plus 1 for x in the other equation. So that is going to give me a negative, and in parentheses, 2y squared plus 3y plus 1, and then plus y equals negative 1. So we have a negative 2y squared minus 3y minus 1 plus y equals negative 1. So then we need to simplify. So we are going to add 1 to each side to get those together. That is going to give us negative 2y squared minus 3y plus y equals 0. Now those y's are going to go together. That is going to give us a negative 2y. Then we need to factor. So we have a GCF of negative 2y. Once we take that out, we will have y plus 1 equals 0. So we will have negative 2y equals 0, and then y plus 1 equals 0. So when we divide by negative 2, we'll have y equals 0, and then y equals negative 1. So then for each of these, we're going to have to plug it back into one of the equations to find x. So we are going to plug this in to the bottom equation. So we'll have negative x plus 0 equals negative 1. So negative x will equal negative 1. And so divide by a negative 1, and x will equal 1. So our full coordinate here for this is 1, 0. But then we have a possibility of another coordinate with our negative 1 for y. So we'll have negative x minus 1 equals negative 1. And then we'll add 1 to each side. Those will both cancel out. So negative x will equal 0. So x will equal 0. So for this equation, we have 0, negative 1. And there we go. So both of these are solutions because that line will actually cross the quadratic in both places. So it probably looks something like that. So for example 2, we are actually going to do elimination for this system. So we are going to go ahead and put everything on one side of the equation. So we are going to, on this top equation, subtract y and the 5. So we will have x squared minus y minus 5 equals 0. Now I do need to leave a little bit of room because we do have a linear term on the second equation that we're going to need to line up. So we're going to subtract 7 on each side over here. So we're going to have a negative x plus y minus 7 equals 0. And then we are going to add those together. So we have nothing to add to x squared or our negative x. Our y's will cancel. And then we will have a negative 12 equals 0. So then we can solve this equation by factoring. So we are going to have two numbers that multiply to be negative 12 and add up to be a negative 1. So that is going to be x minus 4 and x plus 3, and that equals 0. So x minus 4 equals 0. So x equals 4, and then x plus 3 equals 0. So x will equal negative 3. So then I will need to plug each of these in to one of the equations to find what y should be. So I'm going to use that bottom equation again. And so I'll have a negative 4 plus y equals 7. And then y equals 11 when I add the 4. So then we have minus a negative 3 plus y equals 7. So 3 plus y equals 7. We'll subtract 3, so y equals 4. So I'm going to have 4, 11, and then negative 3, 4. So those are both solutions because we probably have another situation where that line is crossing twice. All right, so now let's look at a word problem. So we have a software developer determines that her company can model their revenue R from a given product in hundreds of thousands of dollars given the unit price of a product X in dollars with the function R equals negative 0.1 x squared plus 4x. And then we need to create a linear quadratic system to solve it graphically to determine the price for which the company will earn 4.2 million. Okay, so the kicker here is that this is in hundreds of thousands of dollars. So 4.2 million, actually we need to figure out how many hundreds of thousands we have. Okay, so 4.2 million, if we actually write it out, is, see, 4,200,000. So we actually have 4,200 thousands of dollars. So we have one equation that's going to be y equals 42. And then the other equation is already given to us, that negative 0.1 x squared plus 4x. So what we're going to do is we are going to go and put these equations into Desmos and see where and if they cross. So let's go ahead and put these equations in. So we have, see, a negative 0.1 x squared plus 4x. And then for our second equation, we will have y equals 42. And so these equations don't cross. And so what happens is we have no solution because they don't cross. So there is no price that can be set for the company to earn 4.2 million. And we know that because our equations don't cross. All right, so for example 4, we have another word problem. So engineers want to build a footbridge that steps across a steep valley. They can model the valley with the equation y equals 0.05x squared minus 4x plus 80. Where y is the height above the lowest point in the valley in feet, and x is the distance from where they plan to start the bridge. So if they start the bridge 80 feet above the ground and want it to go down an inch for every foot to the right, then at what points will the bridge start and end? So we have one equation here that we need to use as part of our system. So we need to write an equation for the other side of our system. So we are given that they want to start the bridge at 80 feet above the ground. So that can be like our y-intercept for our line. And then they want it to go down an inch for every foot to the right. So that is 1 inch over for every foot. So every foot is 12 inches. So that could be our slope. And so since it's -1/12, it's in terms of feet. So we don't need to do anything to the 80. So we could actually put this in our graph and then be able to solve it. So for our first equation, we had y equals 0.05 x squared minus 4x plus 80. So that gives us our parabola. And then for our linear equation, we have a -1/12 x plus 80. So this gives us 2 points that we're crossing. So I can click on either of these and get the points. So we have 0, 80. And then we have pretty much 78.3 and 73.47. So those are the solutions to the system. So the bridge will start at (080) and end at 78.3 and 73, I forgot what that decimal is, 0.5. We'll just round it to a tenth. All right, so for solving quadratic systems or any other system, we are going to graph these. So you can have horizontal parabolas that look more like they're going from side to side. And so as a result, if you have a horizontal parabola and a vertical parabola, you can actually have up to 4 intersections. So if you do have 2 quadratic relations at all, it can have from 0 to 4 solutions. So you can solve these with either algebraic or graphical methods. Usually the way to go though is graphing. It's going to give you a visual. You can visually check and see if you have all of your solutions. Just remember, you can have up to 4. So it's a way for you to just kind of check things off the list and make sure you have it all. With solving it algebraically, that's a little bit tougher. So let's go ahead and put example 5 into Desmos. And another thing with equations like this too, your TI calculator will not always do these because you have to solve for y. So that makes it a little bit difficult. So we have y equals x squared. And then we have x equals 1/5 and y minus 6 squared plus 6/5. So we just typed it in exactly as it sits. And of course, we've got like kind of a little mess going on over there. But in this case, we only have 2 intersections. So we have 2, 4, and we have 3, 9. So those are where we cross. So we have 2, 4. So we only had 2 on that one. So I do want you to go ahead and pause the video, try to graph this one in Desmos, and then see how you do. Okay, so you should have that graphed in Desmos. Let's look and see what we get. So you have y equals negative x squared plus 5x minus 6. And then you've got 3y equals x squared minus x minus 6. So again, we only have 2 spots where these cross. And so that gets you 1, negative 2, and then 3, 0. All right, so for this next system, we have, let's see, 2x squared minus y equals 4, and y equals negative 1/2 x squared plus 6. So let's go ahead and get this graphed. So we have, let's see, again, 2x squared minus y equals 4, and then y equals negative 1/2 x squared plus 6. So this time we again only have 2 solutions. So it's where our lines cross. So we have negative 2, 4 and 2, 4. All right, so for this last example, I want you to go ahead and put it into Desmos and try it on your own. Then when you are done, hit play so you can see how you did. All right, so let's go ahead and see what we got when we graph. So we should have x equals, see, 1 over 18 y squared. And so that is giving you one of those horizontal parabolas like I told you guys about. And then we've got y squared equals negative 18x. And then plus 72. Okay, so we have two spots that these intersect. And those are at 2, 6. I'm going to have to shrink this just a little bit. And then at 2, negative 6. So 2, 6 and 2, negative 6. So there we go.